Chapter 1.8, Temperature and the Zeroth Law of Thermodynamics. Yeah. So this will be continuation, the third video or the last video for this chapter 1. Yeah. So the Zeroth Law of Thermodynamics states that if two bodies are in thermal equilibrium with a third body, they are also in thermal equilibrium with each other. Okay, like example, if you put iron and copper together, iron is 150 and then copper is 20. What happens at the end of the day? Both the body will be actually attaining 60. And let's say if you replace the third body with a thermometer, let's say you stick a thermometer inside here, the thermometer will also attain 60 degrees at the end of the day. Yeah. So this is what it says by the Zeroth Law of Thermodynamics. Yeah. So we have temperature scale where the ice point, the reference is always water. Yeah. Water at 1 atm. Yeah. So ice point will be at 0 degrees. 0 degrees C is ice point at 1 atmospheric. The steam point will always be 100 degrees C. Okay, there are some units that we'll be using throughout the lesson, and there are some that we don't look at it. Yeah, but you need to know we use Celsius and we use Kelvin. Yeah, Kelvin scale. Okay, Fahrenheit, we don't use this English unit, Fahrenheit and Rankine. Okay, you know what Celsius is given by C, and Kelvin would be the what do you call this? Kelvin is the absolute temperature. Yeah, absolute temperature value. Okay, so we have the Kelvin scale. So Kelvin is given by K, and there's no degrees. Okay, and there is a conversion. We will see the conversion in the next slide. Okay, so what we have here, the conversion. To get Kelvin, you take the degree C plus with 273.5. Okay, always remember one increase of temperature, 1 unit of temperature is equivalent, yeah, to Kelvin. It means one hike in 1 degrees of Celsius is equivalent to one Kelvin, 1 unit of Kelvin. Okay, that's the meaning. We are not too much interested in Rankine and Fahrenheit. Yeah. Okay, there is a point where ice point will be for 0 degrees. Yes, steam point, you know, it's 100 degrees. And there is another point which is called the triple point. Triple point is a state where all the 3 phases, they coexist in equilibrium. Okay, we will see that in chapter 3. Okay, triple point. Yeah, if you see, you have all the phases. You have the liquid, you have the vapor, you have the solid, all existing in the same point. Yeah, that's the triple point. Okay, this one you can just read through yourself. This is the International Temperature Scale. It's nothing, just that some knowledge for you to know. Okay, next would be pressure. So what is pressure? Pressure is force over area. Yeah, force, Newton over area. Okay, it is 1 atm is equivalent to 101325 Pascal or 101.325 kilopascal. Yeah, so area plays an important role on pressure as well. So if a fat person, look at that, the pressure is 0.46. Just because the area, if let's say both the area is 300, yeah, and this person will be having more pressure on his foot compared to the one that is 68. Yeah, so we have absolute pressure, gauge pressure, and vacuum pressure. What is the absolute pressure? It's the actual pressure that's given position. It is much related to absolute vacuum, and gauge pressure is the difference between the absolute pressure and the local atmospheric pressure. Most pressure measuring devices are calibrated to 0 in the atmosphere, so they indicate gauge pressure. Yeah, and vacuum pressure is a pressure that is below the atmospheric pressure. Yeah, it's usually vacuum. There's nothing, you know what's vacuum, right? Okay, so it's like no pressure at all. I mean, it's vacuum. Yeah, so vacuum pressure is defined as atmospheric minus absolute. Okay, now gauge pressure is pressure absolute minus with atmospheric. So now the variation of pressure is affected by the depth, definitely, yeah, because it is rho g h. Yeah, so the deeper it gets, so the higher the pressure would be. Yeah, rho g h. Okay, I'm going to come to that. Okay, if you see, the pressure at the bottom here will be the atmospheric pressure plus with the pressure due to the depth. Okay, let's look at this. So pressure, as long as it's the same line, Oh, sorry. Oh, same line. I'm trying to draw a same line here. Okay. As long as it is the same line, the pressure in the along this line will be the same. It means pressure A, pressure B, pressure C, D, E, F. No, sorry. This is F and G will be the same. Okay. So how do you calculate this pressure? Okay, it will be pressure atmospheric, which is at the surface, plus with rho g h, the height. Rho g h. H will be the height from the surface. So that's how you get your atmospheric plus rho g h. Now pressure in RH and I is not the same. Why? Because this is mercury, and even though the depth is the same, but then because it's mercury, it's different substance. So this will be rho g h. What is this height? This height will be from here to here. Okay, okay, so that's done. Okay, let's move on to Pascal law. So Pascal is a great scientist, yeah. Because of Pascal, we can use the advantage of hydraulic lift and hydraulic system. Yeah, sorry. Okay. Now, what does Pascal say? The pressure applied to a confined liquid increases the pressure throughout by the same amount. So, force over area equals to force over area. Yeah. You have to compare between the same area, like force 1 divided by area 1 equals to force 2 divided by area 2. So look at this. This force, just a little force imposed, because of the area here big, you can actually push up this whole car above. So this is the concept of using the Pascal law. Yeah. Okay. Next we'll be moving to manometer. So manometer is a device that is used to measure pressure. Yeah. Okay, so observe this. What is the pressure at 1? Pressure at 1 will be atmospheric plus with rho g h of this fluid plus with rho g h of this fluid. Now h, remember, it is dependent, okay, of this height only. Don't go and take from up to down. No, cannot. Use this height, h2. And then we have h3. Okay, so what is the total pressure? The total pressure at bottom here would be atmospheric plus rho gh1, rho gh2 and rho gh3. That's how it works. Okay, now remember, as long as the height is the same, the pressure will be the same. But of course, this is a different fluid. So this is rho gh, rho of this fluid. Okay, and at this point here, this will be rho of this fluid. Okay, so how do you want to point 1? Very easy. You just have to take atmospheric plus with rho gh. That would be 0.2. 0.2 is equivalent to 0.1. Okay? Okay, that's done. Now let's move on to other pressure devices, like how we do the lab experiment. In lab, we do many other types of thermometers. But here, these are the types of measuring devices: Bourdon tube, pressure transducer, strain gauge, pressure transducer, piezoelectric transducers. Yeah, so different devices uses different concept. Next would be the barometer and the atmospheric pressure. Atmospheric pressure is measured by the device called the barometer. So this is a barometer pressure. You have done this in lab, in your physics lab in school before. Yeah, what you need to do, you take a tube, fill up with mercury, and then submerge the tube into a bowl of mercury. So you will see that this thing will be evacuated. It's a vacuum, and the height here, yeah, it will form a height, it will drop to a height. So how to calculate this is actually atmospheric pressure equals to rho g h. So the height that it will fall to will be standard 760 mm. Yeah, 760 mm for mercury. Okay, so this is also another measurement of standard atmosphere. Okay, so you can do this in the lab. Okay, now how to solve problems. This is the steps that you need to actually go through. First, you read the problem statement, then you look at the schematic diagram, you make appropriate assumptions, and then you apply laws, and then you look up for the properties, and then you calculate, and then you reason out your answer. Okay, so these are the steps involved, and we have actually come to the end of the chapter. Okay, so the summary, we have studied all this particular sub-chapters and chapters. So we are done with chapter 1. Yeah, and I have to go through example 1.6 with you. So this is example 1.6 from the textbook. Let's look at it. Measuring atmospheric pressure with a barometer. Determine the atmospheric pressure at the location of the barometer reading 740 mmHg, and the gravity acceleration is 9.805 meter per second. Assume that the temperature of the mercury is 10 degrees, at which density is 13,570 kilogram meter cube. So how do you solve it? The barometer reading at the location in the height of the mercury column is given. So the atmospheric pressure is to be determined. So you know the temperature is 10 degrees. So the density mercury is this. So from equation 1 to 3, which is atmospheric pressure is rho GH, you just have to take the rho, which is given in the question. The gravity is also given in the question. And the height, which is 0.74 meter. Did you see the unit is being changed? Yeah, because the whole thing is actually in meter, so we don't want to also use millimeter. Yeah, and then this part, this behind part here is the conversion. 1 Newton is equivalent to 1 kilogram meter per second square, and 1 kilopascal is 1000 Newton meter cube square. So from here you can just cancel off and you can get 98.5. If you have any issues, any questions that you don't understand, please meet me during the consultation hours. Thank you.